Get started on the problem 9 on the review for the final. We have 3x squared minus 6x plus 5 and g of x equal to negative 3x plus 23. And we're asked to complete a set of tables to find the x values where f of x equals g of x, which is a clue that there's an easier way to solve this algebraically. We're just finding the solution where this quadratic equation, which is the 3x squared, that's the quadratic equation, and the linear equation is the line, is that exponent, the leading variable has an exponent of 1, so it's just a straight line. Does this thing, for that matter, intersect just once? Like this, maybe? Maybe there's a third dimension where it intersects, which is going to require an imaginary number line, believe it or not. I know it sounds cartoonish, but we call it the imaginary number line juxtaposed to the real number line where we plot what are called complex numbers. That's where the discriminant comes into play. But first, given the clue where they're equal, where f of x equals g of x, well, we can just set these two equations equal to each other. So I'm going to go back to blue. I like blue. 3, it's supposed to be blue. Rather trivial matter, but there we go. 3x squared minus 6x plus 5. We're going to set that equal to negative 3x plus 23. Okay, plus 23. So we're going to deploy the addition property of equality, or the equality property of addition. So we're going to add the same terms on both sides, in other words. So that's going to be adding 3x, so that negative 3x plus 3x equals 0. If we add it on the right-hand side, we have to add it on the left-hand side, and we're going to combine like terms in that regard. So that's negative 6x plus 3x. And then same thing with the 23, that's positive 23. It's like unthreading a needle or undoing a knot. Say if you were helping your kid, brother, or sister tie their shoes and they had a knot, well, you'd get the knot out, you'd do the reverse. So reverse of positive 23 is negative 23. Those cancel out, minus 23 on this side. And then, well, 3x squared, nothing changes there. And negative 6x plus 3x is going to be negative 3x. And positive 5 minus 23, that's going to be negative 18. So minus 18 is equal to 0, because nothing's on the right-hand side now. And then you could do the quadratic formula, which is x equal to negative b plus or minus b squared minus 4ac divided by 2a. You could, but we can actually factor this and solve it just as easily without the quadratic formula. But the nice thing is no matter what, the quadratic formula will work, whereas some of the other methods may not. Another thing we could do is do the AC method, but that would also, this would be a waste of time because we're just going to end up having to factor something out anyway. So we could take 3 equal to negative 18, which is negative 54, and then find the two terms that multiply to negative 54 and add up to negative 3. But wait, we're forgetting a step. what's the biggest number or biggest term that goes into each of these? Well, negative 18 doesn't have an x, but what that is, if we factor 18, that's 18 times 1, 6 times 3, and wait, that's negative 3 is just negative 3 times, or 3 times negative 1, and 3 is 3 times 1. So we could factor out the 3. 3 times x squared. X squared has a coefficient of 1. 3 times negative x, so that's negative 1 is the coefficient, and then 3 times the constant of negative 6 equals negative 18, and this whole thing equals 0. Now, instead of the AC method, we're in a much simpler place because we can simply say, well, negative 6 and negative 1, and say, well, we want to find two terms that multiply to negative 6 and add up to negative 1. So the factors of 6 are going to be, well, 6 and 1 and 3 and 2 as far as integers are concerned. Well, the other caveat is that with a negative integer, the only way to get a product that is equal to a negative integer, we need a positive integer and a negative integer. So we would have to have something like, say, 6 minus 1, which is 5, or 1 minus 6, which is negative 5. Neither of those make any sense because we're going to take the two numbers that multiplied into negative 6 and then add them up to get negative 1. So what about 3 and 2? Well, 3 times 2 equals 6. Just one of them needs to be negative. So like 3 minus 2 is 1. But if we flip that, 2 minus 3 equals negative 1. So that works. 2 minus 3. And it doesn't matter if you put this on the left or right with the big X method. I think sometimes it's called the diamond method, but I just put a big X. And then next, we're going to put that in factored form. We can't forget about the 3 over here for proper notation. So that's 3 times x plus 2 times x minus 3. And then the whole thing is equal to 0. Well, we want to solve for x. So we can now forget about the 3, and that's x plus 2, x plus 2 is equal to 0, and x minus 3 is equal to 0. And, well, in that event, x plus 2, well, we subtract 2 on both sides, so we have x equal to negative 2, and then we have x plus 3 on both sides, so we have x equal to positive 3. So the two answers are negative 2 and positive 3, which technically you don't really put the positive sign there, but you can. Nothing wrong with that. So those would be our two answers. And also the reason why that 3 can be dropped, technically I guess you could say it's still there. In the original form, if you say 3 times negative 2 plus 2, well, that whole thing is going to equal 0 because negative 2 plus 2 is 0, and 0 times 3 equals 0. So there you go. And then same thing over here. You have positive 3 minus 3. You have 3 on the outside. Well, 3 minus 3 is 0. 0 times 3 is also 0. And without having to fill in all the boxes, you know that the whole answer is positive 3 and 2. And then if you wanted to do the discriminant beforehand, that's sort of like the magic 8 ball or the tea leaves. in math, all you have to do is, oh, I forgot to put this square root notation. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. But that b squared minus 4ac is our discriminant. And b in this notation over here, well, a first is equal to 3, and b is equal to negative 3, and c is equal to negative 18. And then if you take b squared, well, b squared is negative 3 squared, which is positive 9, minus 4 times a, which is 3, times 4ac. C is negative 18. All right, and then first of all, that's a negative times a positive, which is a negative. And then a negative times a negative always equals a positive. So we know the answer to that is going to be positive, and that means we have 4 plus something, and 4 plus something is going to be greater than 0. And the rule is that if the discriminant is greater than 0, then you have two real solutions. If the discriminant is equal to 0, you have one real solution, and if the discriminant is less than 0, then you have two complex solutions, where again you would map it on a imaginary number line, so it just means you have 3 dimensions. And you should get 225, by the way, because 3 times 18 is 54, and well, negative 54, but then you multiply it by negative 4 and add 9, you get 225, and then the square root of 225, if you were to plug it into the quadratic formula, is 15. And if you have a perfect square, that also means you're going to have 2 integers as your answer as well. So that is a wrap. Once again.